Hey, welcome back. In this next video on related rates, I'm going to explain to you a little bit about the recipe that's been used so far inside the examples, and then go through 3 more problems. The recipe that has to be done in all related rates questions, and actually all mathematics problem solving questions, is we have to convert a paragraph of text into mathematics. Sometimes that's really easy, and sometimes that's more challenging. When we're reading, we have to be able to decode appropriately. If you see a quantity referred to as a rate that's decreasing or a rate that's increasing, that's referring to derivatives, instantaneous rates of change. Decreasing quantities correspond to negative derivatives. Increasing quantities correspond to positive derivatives. So that's one thing we have to do. We have to be able to decode that paragraph. Then the next thing we have to do is we have to take the information that's given to us and in some way relate it to the information that the question is asking us for. For example, if we're given a function that with revenue and cost, and we're asked about profits equal to revenue minus cost. If we're given 2 sides of a triangle and we want to find the third side, Pythagorean theorem. If we're given a length and a width and we're asked for an area is length times width, and so on. So we build some model or some expression that connects the knowns to the unknowns. Once we have that expression, we have to do implicit differentiation. That expression will involve functions of time or functions of x or functions of something. We'll take the derivative according to that hidden variable. So anything like say h to the power of 3, we would take that derivative as 3h squared times h prime. Just like we would take the derivative of y to the power of 3. Once we have everything taken the derivative of, we can start summing in numbers. In that process, we may find that we're missing some information or missing some data, so that will involve making assumptions. So an assumption that's we already made one of the previous examples is that the ladder has constant length. It does not get longer when you bowl the bottom. Maybe it does a little bit, but we're going to assume it doesn't. And there's other assumptions that we make. For example, that everything meets at 90 degrees if we're talking about triangles. So you may have to go back and check the assumptions and see what else you have to do. So let's look at this one. A triangle has a base b of t and a height h of t, so it's explicitly telling you that those 2 quantities are changing. At this instant of time, the base is 10. So at this instant, it says the base is 10 and is increasing at a rate of 3. B prime is equal to 3, so something increasing, positive rate of change, so B prime 3. At the same instant, the height is 5 and is decreasing at a rate of 1. So h prime is negative 1. Again, decreasing means negative derivatives. Okay, what is the rate of change of the area of the triangle? So that's what we want. We want a prime. When we put all this together, we need an expression that connects the area to the other data, the base and the height. Well, the area of a triangle is 1/2 base times height. Now we'll take a derivative. What rule do we need? We need a product rule. So we have the first function, so 1/2 times b, multiplied by the derivative of the second, so times h prime, plus h, multiplied by the derivative of the first function, 1/2 of b prime. So the first function times the derivative of the second, plus the second function times the derivative of the first. And now we can plug in our data. So 1/2 times b times h prime plus h times 1/2 times b prime. And plug in what we have. So b is 10, b prime is 3, h is 5, h prime is -1, and then simplify. So we have 10/2 times -1, so -5. And then we have plus 5 times 3, 15, over 2. We have to make a common denominator, so -10/2 plus 15/2. We have -5/2 for our rate of change of the area. So the area is getting smaller with time. And I'm just going to quickly double check and make sure I have all of my numbers plugged in correctly. Yeah. Okay, another example. Person is sitting in a chair. Sounds safe. 4 meters away from a launch pad of a small rocket. Better be really small, 4 meters away. At this instant, the rocket is 3 meters above the launch pad with an upward velocity of 20 meters per second. Find the rate of change of the distance between the person and the rocket at this moment. You better draw this. You better not try to solve these without drawing a picture, or you're going to get it wrong. I'm going to start by drawing the launch pad, because that's kind of the center of the action. Low effort launch pad, just a dot. And then I'm going to draw the rocket above it, because it says the rocket is 3 meters above the launch pad. I'll put slightly more effort into my rocket picture. Oh, I'll put less effort, I think. It looks better with less effort than more effort sometimes. Oh, well, since she's here, come here. Come here. Come here. Might as well say hi. Say hi. You gonna wave? Oh no. Oh no. She's hanging out with me today. Go back to your, oh, okay, go back to where you're, whatever you're doing with busy cat business. Okay, so that's the rocket. And I'm gonna give a label for the distance between the launch pad and the rocket. I'm gonna call it H for height. You call it R for rocket if you want. I'm gonna call it H. Creativity is not required for your labels. And we have to now draw the person in the chair. And this person will be green. Okay, so here's the person in the chair. And this person is being safe with safety glasses. Maybe some exhaust from the rocket. Maybe that's enough drawing of things. Okay, now I'm going to label the distance between the person and the rocket and give that, the person on the launch pad rather, and give that a label. I'll call it L for length. We call it G for ground. Doesn't matter. Make a label. Now I want to label the distance, because it's asking to find the rate of change of distance between the person and the rocket. So that's this thing again. So you imagine having a measuring tape that connects the rocket to the person. You want to know what's the rate of change of that distance, and how is this measurement changing? That's the straight line distance between them. So I'll call that D, and I again make a modeling assumption that the rocket is going perfectly straight up, that the ground is flat, and that those angles, that those sides meet each other at 90 degrees. Now I gotta go back and decode the math. So the height is 3, H prime is 20, L is 4. What's L prime? So L is the distance between the person and the launch pad. L prime is the rate of change of the distance between the person and the launch pad. What is L prime? So that person is sitting in the chair, not moving. And the launch pad is just there, like all launch pads, not moving. It's not like one of those mobile missile launch stations. It's just probably a little mark in the ground. It ain't going anywhere. He's not going anywhere. Or she doesn't say anything about the person. L prime is 0. There's no rate of change of the distance between them. That's hidden information. And it's important. Hidden information. It's not well hidden, but it's still not directly told. The person is not moving. All right, let's put everything together. Let's make our mathematical model that d squared is equal to h squared plus l squared. Oh, what do we want? We want d prime. So we'll take the derivative of everything. 2d d prime equals 2h h prime plus 2l l prime. Common factor the 2 from the right hand side. 2d d prime is equal to 2 times h prime plus l l prime. We can cancel the 2's. Okay, and then we're after d prime, so I'm going to divide both sides by d. h prime plus l prime all over d, and then we can substitute in our data. I'll leave brackets for everything. Okay. So 3, 20, 4, 0, and we need to find d. So we'll go back and find that. At this instant, d squared is equal to h squared, so 3 squared plus 4 squared. So d squared is equal to 9 plus 16. D squared is equal to 25. D is equal to plus or minus 5, but it's only 5 because don't make me get the measuring tape. All over 5. Now we can simplify. Now we can multiply the 3 times the 20 and then divide by 5, but it's smarter to do it this way. 3 times 20 plus 0 over 5. Just divide the 20 by the 5 first. So 3 times 4, which is 12. That's our answer. So that's the rate of change of the distance between the person and the rocket as the rocket goes up in the air. Okay, and I'll do this last one in this video as well. This is a hard one. This is the challenge question. The water tank has the shape of a cone. The height is 10 meters and a top radius of 5 meters. Actually, I take it back. I'll do it in a separate video because it is going to take more than 6 minutes.